Example 42. You've been told, use the substitution u is equals to x squared to show that integrating from the interval 0 to 1 of x sine inverse of x squared dx over the square root of 1 minus x raised to power 4 is simply pi squared over 16. Are we together there? So you start, you've been told to take u to be x squared. So it means when you differentiate u with respect to x, you get du is 2x d. Are we together? Meaning x dx is going to be du. So if you divide both sides by 2, automatically you see, you divide both sides by 2, you see is du over 2 is equals to x d. So where you see x dx, you are going to put du over 2, isn't it? Are we together? You go on. Look at sine inverse of x squared. You were saying you remember x squared is u. Is that okay? Is that okay? So you can now say, if you say now v to be sine inverse of x squared, if you say v to be sine inverse of x squared, so it's like you are saying v is sine inverse of u because x squared is u. Are we together? X squared is u. So v is sine inverse of u. So if you differentiate v with respect to u, dv over du, you get, if you differentiate sine inverse of u, you get 1 over square root of 1 minus u squared. Are you seeing that? Are we together? Hello? That is exactly what you get, isn't it? That is exactly what you get. So look at that. You take du the other side, you remain with the dv is equals to du over square root of 1 minus u squared. Put it away. V is sine inverse of u, which is equals to sine inverse of x squared, because u is x squared. That's what you are now seeing, isn't it? Are you now seeing it? Then dv is du over this we found by differentiating this, isn't it? Check it the other side. What is du? Du is, take to the other side, du is 2x dx, isn't it? Meaning where there is du, you put 2x d. See that one you can see clearly. So du is 2x dx over square root of 1 minus u squared. U was x squared. So x squared squared, you get x raised to power. Are you saying you've now connected the three unknowns with the original? So from here, you now see there is 2x has come up. So if 2x has come up, what do? You multiply the numerator by 2 and you divide by 2, isn't it? Are we together? So that 2x dx over square root of this, with the whole of it will be d. Have you seen that? You simply multiply by 2 and divide by 2, so that you get 2x dx divided by square root of 1 minus this, meaning the 2x dx, the whole of this, divided by this gives you the v. Then sine inverse of x squared, the whole of it is v. Have you seen that? So if you look at the original problem where we had x sine inverse of x squared dx over square root of 1 minus x raised to power 4 is simply expressed as, you multiply by 2 and divide by 2 is a half into sine inverse of x squared. Then you have 2x dx over square root of 1 minus, if you rearrange, isn't it? So that the 2x which is here to start, remember I've multiplied by 2 and I've divided by 2, so I will remain with the half outside, then 2x dx. So you see 2x dx over square root of 1 minus x raised to power 4, the whole of that is dv, isn't it? Then you can see sine inverse of x squared is v, isn't it? So in the end we have v dv. Have you seen that? We have v dv, meaning we are integrating a half of v dv, which you get to be a half. If you integrate v, you get v raised to power 2 over Have you seen that? See, this is a polynomial. So you simply add 1 to the power and you divide with the resultant power. Isn't it? Yes, so you get a half v squared over 2. Then you substitute back your value of v. What is v? Sine inverse of x? V is the same as sine inverse of x squared. So where there is v, you start a half divided by 2 is 1 over 4. Then v squared is sine inverse of x squared, which has been squared. Are we together, ladies and gentlemen? Yes. Now, after you reach that level, is when you now introduce your limit of integration from 0 to 1. You are supposed to integrate what? You are supposed to integrate. Hello? Yes. You are supposed to integrate from 0 to 1 of x sine inverse of x squared dx over square root of 1 minus x raised to the power 4. And we found the derivative to be 1 over 4 in bracket sine inverse of x squared all raised to power 2. Then you put your limits 0 to 1, because we found the indefinite integral here. So we come back to the definite integral where we put the limits we were given, isn't it? We key in the limits we were provided with. So can you now go to your calculator and get me, remember 1 over 4 is a constant common for everything, isn't it? Then inside the bracket I have upper limit minus lower limit. 1 over 4 is common for both of them. So you can factorize a common factor outside, isn't it? Are we together? So upper limit when x is 1. So where there is x, if you put 1 squared is 1, isn't it? So sine inverse of 1 is what? What is the sine inverse of 1? Sine inverse of 1 is supposed to be 90 degrees. That is pi over 2, isn't it? Because that pi over 2, isn't it? You must deal in pi radians. Pi over. So this is pi over 2. Then there is square outside, meaning pi over 2 squared, isn't it? So pi over 2 squared, you get pi squared 2 squared, you get. See, you have inside the bracket, you have pi over 2, then it is square. See, that is pi squared 2 squared. Lots of indices, isn't it? Isn't it? Good. So this one becomes pi squared over 4. Then the lower limit, sine inverse of 0 is 0. 0 squared is 0. Quarter times 0 is 0. So that one is 0. So pi squared over 4 minus 0 is just pi squared over 4, isn't it? So if you simplify this, what do you get? 1 over 4 into pi squared over 4. In the numerator is 1 times pi squared. Is pi squared in the numerator 4 times 4, 16. So you found pi squared over 16. And that is exactly what they wanted you to find. Have you seen that? Are we together? Very simple. And you really like that.